section, we will talk about linear and absolute value inequalities. When using a less than or greater than inequality, we will use an open circle or parentheses. For less than or equal to or greater than or equal to, we will use a closed circle or a bracket. When approaching negative infinity or infinity, we will use a parentheses when writing interval notation. Let's graph the following inequalities and write the solution set in interval notation. Our first example is x less than or equal to 6. So first thing we have to determine is the number 6 included in our solution set or not? Since x is the set of all numbers that are less than or equal to 6, that means the number 6 is included in our solution set. And we indicate that using a bracket. Then we have to determine, is our solution set approaching negative infinity or positive infinity? Since the set of all numbers x are getting smaller and smaller, they're all less than or equal to 6. If they're getting smaller and smaller, they're going to approach negative infinity. So we will use a bracket to indicate that the number 6 is included, and x is the set of all numbers that are less than or equal to 6. So we included 6. Now to go less than, we will shade going towards negative infinity. In interval notation, we will take this graph and we will write it using a parentheses and a bracket. So in interval notation, we have our lowest value and our highest value in that order. The lowest value of our solution set is a negative infinity, and the highest value is a positive 6. For negative infinity, we always use a parentheses because infinity is a concept that numbers keep getting infinitely small. It's not an actual number, which means we cannot include it in our solution set. So we always use a parentheses when we approach negative infinity or infinity. But the number 6 is included, so we will use a bracket. And notice the order is the same as shown on the graph, negative infinity, comma 6. In example B, we want the set of all numbers that are greater than negative 2. So we have to determine, is the number negative 2 included or not included? So in this case, we strictly want the set of all numbers that are greater than negative 2, which means negative 2 is not included in our solution set. So we are going to put parentheses on negative 2 since negative 2 is not included. And since we want the set of all numbers that are greater than negative 2, the numbers get bigger and bigger. And when numbers get bigger and bigger, they will approach positive infinity. So in interval notation, the smallest value in our solution set, well, is negative 2, but not including negative 2. So we'll put parentheses negative 2, and the numbers are approaching infinity. So our solution set notation will be negative 2, comma infinity. Next, we want to solve this inequality, graph it, and then write the solution set in interval notation. To solve the inequality, we will use the same steps as an equation with 2 exceptions. So here are the 2 exceptions. Exception number 1. In equations, we can move the variables to the left or to the right. It doesn't make a difference. In inequalities, the variables always move to the left. Variables always move to the left side of the inequality. Secondly, if we multiply or divide both sides by a negative, then the inequality reverses. Okay, so let's follow these rules and solve our inequality. So the steps are, 1, to eliminate any fractions, which we don't have. The second step is to distribute, which we don't have. Third step is combine like terms. There are no like terms on either side of the inequality. The next step is to move all variables to one side. Now, normally, in an equation, we can move the negative 12x to the right if we wanted to. But one of the rules for inequalities is the variables, they always move to the left. So we are going to add 3x to both sides. The variables always have to move to the left. This gives us 5. Negative 12 plus 3 is negative 9x, and that is greater than or equal to negative 22. Then we move the 5 to the right by subtracting it. So we subtract 5 from each side, And this gives us negative 9x is greater than or equal to negative 27. Now the x is being multiplied by negative 9, so the inverse of multiplication is division, so we divide both sides by negative 9. And here's where we have to be careful. When we multiply or divide both sides of an inequality by a negative value, the inequality will reverse. So we will have x less than or equal to positive 3 as our solution set, which means we want the set of all numbers that are less than or equal to 3. So the number 3 is included, which means we will put a bracket on 3. And we want the set of all numbers that are less than or equal to 3. So if you want the set of numbers that are less than 3, the numbers will get smaller and smaller, and they will approach negative infinity. So the lowest value in our solution set, well, we're approaching negative infinity, so I'll put negative infinity on the left side of the interval notation, and our solution set stops at 3. So the highest value is 3, including 3. And this is our answer in interval notation. Let's do another example. In this inequality, we will first have to distribute the 2. So 2 times 14x, that's 28x. 2 times 11, that's 22. That is less than 20 plus 7x. Remember that the variables will always have to move to the left side in any inequality. So we move the 7x to the left by subtracting 7x. This gives us 21x plus 22 less than 20. The next step is we subtract 22 from each side. So this gives us 21x is less than negative 2. Then we divide both sides by 21, and we have x less than or equal to negative 2 over 21. Now, we don't want to leave our answer in decimal form. We do want to have it in exact form unless it's specified. But one thing we want to do is when we graph this, we have to keep in mind negative 2 over 21. What is that approximately equal to? So in decimal form, negative 2 over 21, if we divide in a calculator negative 2 divided by 21, this will give us approximately negative 0.1 if we round it. So we know that negative 2 over 21 is going to be somewhere between 0 and negative 1, but very close to 0. So it's going to be approximately right about there. Then we got to determine, do I use a parentheses or a bracket? And I accidentally put an equal sign, but it is just a less than. Also notice that because we divided both sides by a positive, the inequality did not reverse. So we have x less than negative 2 over 21. So approximately right there, I'm going to put a parentheses. Less than means the numbers are getting smaller and smaller. So I'm going to shade going towards negative infinity. And my solution set is going to be negative infinity, comma, negative 2 over 21. And in this case, because I have a less than, I do not include negative 2 over 21, and I will use a parentheses for negative 2 over 21. Okay, the next example we will do in class. Now let's talk about an intersection and a union. The intersection of two sets, denoted by A intersection B, the symbol represents intersection, is a set of all elements that belong to both sets A and set B. So quick example. Let's say set A is 1, 2, 3, 4, and 5. Set B is 5, 6, and 7. Then the intersection of A and B, it's the elements that belong to both sets. So the only element that belongs to both sets is 5. So the intersection of A and B will just be 5. However, the union of both sets is a set of all numbers that are either in set A or in set B, or both in sets A or B. So I'll use the same sets, but in this case, if I do the union of A or B, this means we have to include all the elements that are either in set A or in set B, or both. So 1, 2, 3, 4, and 5, these are all in set A, so I have to include those. Now 5 is also in set B, which means I don't have to write that twice. And then set B also has 6 and 7, which means I have to include those as well. Sorry. Okay, there we go. So we have to include 6 and 7 as well, since A or B means we have to include the elements that are in A or in B. So as long as the elements that are in one or the other set, we have to include them in our solution. So or the union includes all the elements from both sets. The intersection only includes the elements that they both have in common. A compound inequality is formed by joining the two inequalities with the word and or. Now let's first look at the union case, or the word or. Here are the steps. Solve each inequality separately and find the union. The union, remember, it means that we want to include everything that is shaded, or everything that is part of our solution set. So first we subtract 1 from each side. This gives us negative 6x is less than negative 24. We divide both sides by negative 6. Remember that when we divide both sides by negative, the inequality reverses. So this will give us x greater than 4. We have the word or in between, so make sure you put the word or. To solve this, we simply divide both sides by 2. But this time, because we divided by a positive, the inequality does not reverse. So this becomes x less than or equal to negative 4. Okay, so let's graph this. Let's start with x greater than 4. Greater than 4, it means that the number 4 is not included. So we're going to put a parenthesis on 4. And greater than, it means we are going to shade it to the right. So this set is a set of all numbers that are greater than 4, which means they approach infinity. Or less than or equal to negative 4. So here's negative 4. I'll put a bracket on that because it's less than or equal to, so negative 4 is included. And less than, it means we are going to shade to the left, which means our solution set is going to approach negative infinity. Now for a union, we include anything that is graphed, anything that is shaded as part of our solution set. So we graphed or shaded the numbers from negative infinity to negative 4. We include those. We also shaded the numbers from 4 to infinity, so we include those. And because these are disjoint solution sets, we join them by using the symbol union. And this tells us that our solution set could be any number between negative infinity and negative 4, or any number from 4 to infinity, but not including 4. Now, the next one is steps for solving a compound inequality involving the word and. So this was the word or. In the next example, we're going to use the word and. So same thing, we solve each inequality separately, but this time we want to find the intersection of the two sets. So if I just solve this, 1 minus 1 is 0, so I get 5x greater than 0, and I divide by 5, so I get x greater than 0. I have the word and in between. Here I have negative x greater than or equal to negative 8. There's an invisible 1. So if I divide both sides by negative 1, I have x less than or equal to positive 8. The inequality reverses because we divided both sides by negative, and we have the word and in between. Okay, now let's go ahead and graph these. So x greater than 0. Greater than 0, it means I'm going to put a parenthesis on 0, and we want the set of all numbers that are getting larger and larger, so they're going to approach infinity. Second one is x less than or equal to 8. So for less than or equal to 8, I need one more little dash here. This is 8. So less than or equal to 8, it means I'm going to put a bracket on 8, and I'm going to shade going to the left because these numbers are getting smaller and smaller. Now, because we have an intersection, we only want to include the numbers that are part of both sets. In other words, we are looking for the overlap or the intersection, which happens right in the middle between 0 and 8. So the smallest value in our solution set is 0, and the largest value is 8. And only the numbers between 0 and 8 are part of both solution sets.